This AI system just created and published 5 viral POV videos in the last hour without me creating the videos at all. Alright, so take a look at this TikTok account. POV videos like these are exploding across social media right now. But we're talking tens of millions of views, with accounts gaining like 400,000 followers from just 15 videos. But here's what most people do not know. You can completely automate this entire process using AI and no-code tools. No filming, no editing, and no daily content creation stress. While other creators are burning out making one video per day, this system can pump out professional POV videos every single hour if you wanted it to. And the craziest part, you literally just set it up once, walk away, and then watch your channel grow on complete autopilot. Now, I'm about to show you exactly how to build this $10,000 automation system using 3 AI agents that work together. An ideas agent that generates endless video concepts, a production agent that creates the actual videos with AI-generated images, animations, and sound effects, and third, a publishing agent that posts everything to your social channels automatically. So that by the end of this tutorial, you're gonna have a complete Faceless video empire running 24/7, generating content that could potentially reach millions of people while you sleep. And since we are using no-code tools, even if you've never built an automation before, you can have one running today after this video. I added the AI tools that we are going to use in the description below, so you can go ahead and check them out too. It's always easier to follow along when we know what we're working towards. So before we dive into the actual build, let's go ahead and start with a quick demo so that we can see exactly what the finished workflow looks like in action. And this way, we'll understand the bigger picture before breaking it down step by step. And after we see how smooth it runs, the build itself will make a lot more sense. Alright, so seeing that demo gives us the full picture, but the real question is, how do we actually build this from the ground up? So let's rewind to the very first step and then start setting up the structure that makes everything run for us. Okay, so we're going to begin by setting the foundation that keeps the workflow moving on its own, of course. Instead of needing to hit run every single time, let's make it automatic so it's always working in the background. In order to make that happen, we'll add an on-schedule trigger node. Now this is going to be the heartbeat of our system. It decides when everything starts. For this build, we'll set the interval to hours and keep the number at 1, which means the workflow will repeat every hour. Leaving the minute at 0 means we're telling it to fire exactly at the top of the hour, keeping everything neat and predictable. Okay, so this way, no matter when the last run ended, the next one will always line up perfectly on schedule. After that, we're going to execute the step just to confirm that it's working. And it may seem like a small setup, but this trigger is what transforms the workflow from something that we have to babysit into something that's fully automated. And from here on out, every hour on the dot, the workflow will come alive and start running without us doing a thing. All right, so after setting up our workflow to run on schedule, the next piece is giving it the content that it's actually going to work with. Now in the demo earlier, we saw how everything began with a table of POV prompts. And this is exactly where we're going to build that foundation. And to do that, we're going to head back into ChatGPT and we're going to ask it to generate a table that includes all the details that we need: a unique ID, a short POV idea, a caption, and a production status that's always set to for production, an environment prompt to describe the video setting, a publishing status set to pending, and a final output column that's left blank for the workflow to complete later. We are structuring it this way so the table will turn into a clean input source that drops straight into our system without any adjustments. And after setting those up, we're going to copy it directly into a Google Sheet. For example, here, one called POV Topics. Pasting it there will turn the sheet into a simple but reliable database that n8n can connect to whenever it needs new prompts to process. With the data in place, we'll move back into n8n and add a Google Sheets node. Now, this node is what links the workflow to our document so it can fetch the rows we actually care about. We'll set the operation to get rows, connect with our Google credentials, and then choose the resource pointing to the sheet within the document. And from there, we're going to go ahead and select POV topics as the file and sheet 1 as the location. Now, since we want to make sure that the workflow only pulls in active ideas, we'll add a filter that checks the production column and only returns rows marked for production. Along with that, we're going to toggle the option to return just the first matching row instead of everything at once. And that way, the system processes one idea at a time, keeping the workflow neat and manageable. Executing the step at this point pulls in a fresh POV row, ready to flow straight into the next stage of the build. After pulling a POV idea out of the sheet, it's time to shape it into something more than just a line of text. Now, this is where the workflow calls on an LLM chain. Essentially, it's handing the idea to a model and then saying to it, give me a structured version I can actually work with. So we'll start by adding the basic LLM chain node, which lets us talk to the model directly inside n8n. We're not going to rely on pre-built prompts here. We're going to define our own. And that means opening up the prompt field, dragging in the POV idea from the sheet, and then writing clear instructions that tell the model exactly how to format its response. Along with that, we need to make sure it never goes off track, so we'll switch on the option that requires a specific output format. This keeps the results consistent every single run, and designing the prompt is easier if we lean on ChatGPT to help draft it. Once the wording feels solid, we'll copy it over, expand the editor inside n8n, and then just paste it in. The chain is now ready, but it still needs a model provider behind it, so we'll connect it to Open Router. Now, the last step here is to decide how many variations we want. And we're going to set the output number here to 2, and that means we're giving ourselves a pair of creative takes on each POV idea instead of just one. An output parser organizes everything for us neatly into a list, so it's easier to use downstream. Now, when we execute and pin the data, the row from Google Sheets suddenly transforms into 2 polished outputs, ready to feed the rest of the workflows. Now, it's the moment where raw ideas turn into creative building blocks, and it happens all automatically every time the workflow runs. One of the things that makes content really stand out is context. A POV idea on its own can be catchy, but once you pair it with the right environment, like a setting, a mood, or a backdrop, the whole concept feels more vivid and ready to produce. And that's what we're adding here, an extra layer of detail that turns basic ideas into scenarios you can actually picture. And to make that happen, we're going to add another basic LLM chain node. This time, the prompt is designed to combine both the topic from the previous node and the environment pulled directly from the Google Sheet. After authenticating with our model provider, we're going to switch the source for the prompt to define below, which gives us the flexibility to craft the instructions exactly how we want them. And using ChatGPT, we'll draft a clear user message that blends the POV idea with the environment details. And once the wording feels just right, we'll copy it over into n8n, we'll expand the expression editor, and then paste the full prompt in. Now, we're going to connect the chain to a chat model such as Open Router and rename the node to something descriptive like generating prompts to keep the workflow organized. Executing the step runs the request and produces enriched outputs that pair creative ideas with their settings. Pinning the data ensures we can reuse these results in the next stages without having to rerun the model. And what happens here is that every POV now carries not just an idea, but also a sense of place, making it feel production ready. Right now, the workflow has ideas and enriched prompts that read like complete scenarios, but they are still stuck in text form. Visuals are what make them feel real. So rather than relying on design tools or stock photo libraries, the workflow calls Pi API's Flux model directly and generates images on its own. This step transforms written concepts into visuals we can actually use. So here's what we're going to do to set it all up. We'll first adjust the previous node to make space for image generation, and then we're going to drop in an HTTP request node. This is how n8n communicates with Pi API. Since we're asking it to create new images, the method will be set to post. Now inside Pi API's dashboard, we'll head over to the image model section, choose Flux, and click Run API. The URL under text to image is the one we're going to copy and then paste into n8n so that our request points to the correct endpoint. Next, we'll toggle send headers on and add a field called XAPI key, pasting in our Pi API key to authenticate the request. Then we'll switch send body to on, set the body type to raw JSON, and then open the expanded expression editor. From Pi API's documentation here, we can copy an example body, but we'll have to update the prompt field to use the enriched outputs from the previous node. Width and height can also be adjusted here depending on the kind of framing that we want for our visuals. And once everything looks right, we'll execute the step, and Pi API will generate a set of images tailored to the POV scenario. Again, we'll just pin the data here. And with that, we now have custom visuals created automatically, perfectly aligned with the topics and settings we defined earlier. So when we ask Pi API to generate images, the results aren't available instantly. They do take a moment to process in the background. Just like waiting for a photo to render or a file to finish exporting, we need to give the system a short pause before trying to grab the final images. Otherwise, the workflow would just move ahead too early and then return nothing. This step makes sure the visuals are fully ready before anything else continues. So to handle all of that, we'll add a wait node here and then set it to 5 seconds. This small delay gives Pi API the breathing room it needs to finish processing the image request. After confirming the wait is configured correctly, we'll just duplicate the create image node from the previous step so that we don't have to rebuild the request again from scratch. So this duplicated node is then connected right after the wait node, so it only runs once the delay has passed. Inside the duplicated node here, we'll switch the method to get, since we are retrieving results instead of creating something new. Here in the URL field, we'll add a slash and then drag in the task ID from the previous node using the expression editor. That unique ID is what tells Pi API which job we're checking on. Because GET requests don't require a body, we'll toggle the body option to off. After executing the step, Pi API responds with the completed image details, including the final URL we can use later in our workflow. Now, I want to keep everything organized, so we'll rename this node to getImg or getImage, making it clear at a glance that this is where the images are retrieved. Now, given this, we now know the visuals are ready, they're accessible, and set up for the next stage of production. Just like waiting for a download bar to hit 100%, we can't move forward until Pi API confirms that our images are completely finished. And skipping ahead too soon would break our flow, so this step acts like a checkpoint. The workflow double checks that everything is ready before moving on. So for this one, we'll add an if node right after the getImage step. And in the first value, we'll drag in the status field that Pi API returned, and then we'll set the condition to is equal to. For the second value, we'll just type in completed, and that way the workflow only continues down the true path once the job is actually done. Now, on the canvas, we'll connect the false output back to the wait node, creating a simple loop. Now, if the status doesn't come back as completed, the workflow just pauses and waits and then checks again until the images are fully processed and good to go. So far, the workflow already has strong visuals, but they are still kind of like frozen snapshots. Motion adds another layer, turning POVs from static moments into scenes that do feel alive. And what we're going to do here is tap into Pi API's Cling model, which takes the prompts and image references that we've already created, and then transforms them into dynamic video clips that match the scenarios that we envision. So we'll duplicate the create image node here so we can reuse its HTTP request setup without having to start from scratch. So this duplicated node connects directly to the true output of the if node, ensuring that video generation only begins once the image process is fully complete. Inside the duplicated node here, we'll scroll down to the body section and then just clear out the old text to prepare for a new request. From Pi API's documentation here, we'll navigate to the Cling section. We're going to open up Create Task and then copy the example payload. ChatGPT can help refine or restructure the code as needed. In the payload, we'll add an image_URL string so that Cling knows which visual reference to use, and then we're going to paste the modified code into the body of the node with expressions toggled on. From there, we'll drag the enriched prompt from the previous step into the prompt field here and insert the generated image URL into the image_URL field. Now, once everything is wired together, we'll execute the step, sending the request to Pi API Cling. We're also going to rename the node to Create Video to keep the workflow organized. And pinning the data locks in the results so we can reuse them later without triggering the request again. And now our workflow officially moves from still images to fully generated video content. However, once a video request has been sent to Pi API Cling, it doesn't appear instantly. The system needs a bit of time to process before the final clip is ready. And just like exporting a video in an editor, the workflow has to wait and then keep checking until the file is fully rendered. Now, if we skip ahead too soon, we'd only get an empty response back. So this step makes sure the video is complete before we try to use it. We'll bundle the same logic we already used for images to handle this part of the videos. So let's hold Control, then let's select the wait node, the get image node, and the if node, then duplicate them together as a group. Now this creates a ready-made loop for checking video readiness without having to rebuild the whole structure again from scratch. Now, once we duplicate it, the last if node here in the set can be executed to start monitoring the video status. Inside the duplicated getImage node, we'll adjust it to retrieve video results instead of images, updating the endpoint so it points to the correct resource. Now, when the workflow runs here, it will wait, it's going to check the job status, and then keep looping until the video is complete. And at that point, the response will include a video URL that we can confirm and then use in later steps. Again, just like in the other nodes, we need to rename this node to Get Video to keep everything clear in our workflow so it's easy to distinguish from the earlier image retrieval step. So a video without sound does feel incomplete. Even a simple background track can make a huge difference in how a scene comes across. So just like adding music to a short film, this step pairs our generated clips with audio that matches the mood of the POV and its environment. So let's go ahead and bring this idea to life. So here we'll duplicate the create video node so we can reuse the request structure. And inside this duplicated node, we'll clear out the body again and prepare it for a new payload. From Pi API's documentation here, we'll head into the Cling section again. We're going to open up Cling Sound, which provides the request format specifically for audio generation. We'll copy the same code, and then with the help of ChatGPT again, we'll modify the JSON so it fits our workflow's needs. Now, once adjusted, we'll just paste the node into the node body. Then we'll click Expression and expand the editor so that the request loads properly. Next up, let's change the prompt, then update to use the POV and environment values from our Google Sheets, ensuring the audio directly matches the theme of the video. We'll also set the duration here to just 5 seconds, creating short but impactful clips that line up with the generated visuals. When everything is ready, we're just going to execute the step, sending the request to Pi API. And as per usual before, we'll rename the node to Create Audio to keep the workflow easy to follow and pin the data. Now we're going to take the same loop we already built for video. So we just need to hold control again, select the wait node, the get video node, and the if node, then duplicate them together as a group. This gives us a ready-made structure for audio retrieval without having to rebuild it again from scratch. Now with the duplicated flow in place, we'll execute the last if node so it starts monitoring the audio task. Inside the duplicated get video node here, we're just going to adjust the configuration again so it retrieves audio results instead. And when the status finally comes back as complete, the response will include an audio URL that we can check to confirm that the file has been successfully generated. Renaming this node to get audio keeps everything still organized for us and makes it clear at a glance which nodes handle which media types. And with all of that in place, our workflow now reliably captures audio files just as smoothly as it does for images and video. All right, so after all the waiting and the checking, the last thing that we need and we want is to wonder whether the audio actually exists where it's supposed to. So this step is like pressing play on a freshly exported track, and it's our way of confirming that the file is actually accessible and ready to use outside of the workflow. So in order to accomplish that, we need to add a new HTTP request node here, and then set the method to get, since we're simply fetching data rather than creating anything new again. Here in the input section, we'll scroll down to locate the resource URLs that PyAPI returned for the final audio files. And from there, we'll pick up the correct one. We're going to drag it into the URL field of the request node here, and then link it directly to that resource. After executing the step, the request will confirm that the audio file is valid, accessible, and properly generated. And now we know that our audio can be downloaded or handed off to the next stage of production without any surprises. Once the audio is generated, it's not much use if it just kind of sits inside the workflow. We do need a reliable place to store it where it's easy to find, share, and then reuse later. Google Drive is perfect for this because it keeps everything centralized and organized. There's no digging through local folders or wondering, hey, where'd the file go? So this step takes the freshly created audio and then drops it straight into the right drive folder automatically. So let's add a Google Drive node in n8n and choose the operation upload file. After connecting our Google account with the proper credentials as we normally do, we'll set the resource to file and then confirm the operation as upload. The input data field name will be set to data, telling the node which part of the workflow contains the file contents. So for the file name, we'll just map in the prompt from the previous node so that every upload is clearly labeled with its context. Next, we'll choose a parent folder by URL and copying the link of the Google Drive folder here where we want the audio to live, make sure that it does end up in the right spot. And once we're done setting all of this up, we'll execute the step and the audio file will upload directly to Drive. Now, if we check the folder here, we can confirm that the upload was indeed successful. Finally, we'll rename the node to upload audio. So again, the workflow stays tidy and neat and is easy to navigate. And from that point forward, every generated audio clip is automatically archived in a single accessible location. Uploading the audio to Drive is really only half the story because it's not very useful if no one else can access it. So whether we want to hand it off to a collaborator, feed it into another tool, or just grab the link ourselves later, the file needs to be shareable. So this step sets up the right permissions so that our audio isn't locked away and so that it can easily be discovered or edited by anyone with the link. We'll begin by adding another Google Drive node here and setting the operation to share file. Instead of searching manually, we're going to point the node to the exact audio file by ID, and dragging the file ID from the input section ties it directly to the file we just uploaded in Flow 13. Then we'll add a new permission, assigning the role as writer, the type as anyone, and toggling on allow file discovery. Now this combination ensures the file can be accessed, edited, and then surfaced when needed. Executing the step applies the new sharing settings immediately, and from here, our audio files now are no longer trapped inside of Drive. They're ready to be used and shared wherever we need them. Our workflow has produced several valuable outputs. structured titles, generated video, custom audio, and a shared file link in Google Drive. And rather than just leaving them scattered across different branches, this step brings everything together so that the results flow as one complete package. Now, this step brings all the pieces side by side, combining them into a unified result that's ready to use. And we'll add a merge node here now and set the mode to combine, making sure each input is preserved instead of overwritten. When we choose combine by position here, the node matches every input by execution order, keeping everything aligned. And since there are 4 distinct sources to unify, the number of inputs is set to 4 and then linked accordingly. Titles from the generation node, the video branch from the if node, the audio uploaded to Google Drive, and the shared file link. Executing the step consolidates them into one dataset, giving us a nice, neat, unified output that's ready for publishing or any final processing. All the pieces of content are now created, but before handing them off, we do need a way to pull everything into a format that actually makes sense, right? It's like packaging a finished project. The videos, the audio, and the titles are done, but they're scattered. Now, what makes it usable is putting them into one neat bundle where everything has its place. So we need a little custom node right here. And we're going to drop in a code node that takes all of the workflow's outputs and then reshapes them into something structured. The JavaScript for this is already prepared and is shown here on your screen so you can see exactly how it works. Now, what this does is simple but powerful. It sorts the scene titles, the video links, and the audio links into separate arrays, giving us a clean data set that's easy to read, share, or pass along to the next tool. And once the code is pasted in and then executed, that messy pile of results turns into a nice little tidy package. So now we don't have to dig through raw outputs since we're just left with a clear, structured object that captures everything the workflow has produced. It's the final bit of polish that makes the whole system complete. At this point, we've reached the stage where all of the raw aspects are ready. The workflow can generate titles, produce video clips, and create audio files all on its own. But right now, those elements all live as separate parts. What we need next is a way to bring them together into a finished video that feels both polished and consistent every single time. So for this, we will be needing Creatomate. Building a template inside of Creatomate is like sketching the blueprint for every video this workflow will ever produce. And then once that structure exists, we don't need to keep designing from scratch over and over. The workflow just fills in the blanks for us. And that is the idea here. One reusable frame that can accept new titles, videos, and audio every time the automation runs. So to do that, we'll head into Creatomate here, start a blank 9x16 template, and then open the source editor. Inside that editor, the placeholders for scene text, video slots, and audio tracks are defined. They're like empty boxes waiting to be filled. The base code for this is shown on your screen so you can see how it's all set up. And it's simple, 2 scenes, each with its own text, video, and audio element. And from there, we can tweak and rearrange however we like, shifting text positions, adjusting where the video sits, or renaming audio slots so that they match our project. Once the template feels solid, we'll hit Use Template in Creatomate and then grab the C URL they provide. Now back in n8n, an HTTP node is where that C URL goes. Instead of typing requests by hand, just pasting the C URL imports the exact request we need, already formatted correctly. And from here, a code node can step in to modify the template body, swapping placeholder text with real titles and plugging in actual video and audio links. After we execute, the workflow isn't just sending a test, it's updating the template in Creatomate with live content. Again, pinning the data locks in the response so that future steps always know which template they're working with. And what we've built now is a reusable foundation. Every time the workflow runs, it can spin up new videos without ever touching the Creatomate editor again. All the content has been generated and processed, but we still need a way to send that progress back to our Google Sheet. Now, the sheet started out as a list of ideas marked for production, and this is where we close that loop by updating those same rows with the results our workflow has created. Instead of staying static, the sheet becomes a living tracker showing what's finished, what's ready to publish, and linking directly to the final outputs. And to make all of that happen, we'll duplicate the get rows node here we used earlier, since it already knows the sheet and column structure. This time though, we're gonna change the operation to update rows, which lets the workflow modify existing entries instead of just pulling them in. The match column here will be set to ID, so each update targets the right row. For the ID itself, we'll use the value from the get rows node. Now, at first, this reference is highlighted in red because n8n doesn't know which item to use in a multi-item context. So to fix that, we'll correct it by changing the item to dot first and then parentheses. And that way, the workflow knows to apply updates to the correct row without any confusion. And now that the targeting is sorted out, we can prepare the fields that need updating. Production is marked as done, publishing is updated to for publishing, and the final output field is filled with the URL generated earlier in our workflow. And executing the step applies all of these changes, and if we check the sheet here, it confirms that the right rows have been updated with fresh information. And the result is a dynamic log that always reflects the latest status, making it clear which ideas have moved all the way from concept to finished content. And that's a wrap. That's exactly how you can pull everything together and then build a $10,000 Faceless AI video automation with n8n. Thank you for watching and spending your time with me today. I'll see you at the next one.